Hello students! In this video, I'm going to provide you with a complete and effective revision guide to applying the binomial theorem. So please stay till the end. Let's look at the concepts needed to solve problems using the binomial theorem. Concept number 1, we should be able to expand a binomial expression using the binomial theorem. Concept number 2, we should be able to use the general term to find the term independent of x or any other x term. And concept number 3 is to understand some basic properties of the notation and choose R. Right, let's look at the questions that require us to do a simple expansion using the binomial theorem. Right, so the first thing that we need to do is just to do a comparison. That means to compare with what you are asked to expand with the variables given listed in the binomial theorem. Right, so if you look at the screen, the one highlighted in blue, right, will show you that we can replace the values of A with 1. The values of B in the binomial theorem, we can replace it with negative px. Right, look at the arrow here. This is a very important point to take note. The values of B is negative px, highlighted in yellow for you. Let me emphasize again. So therefore, when you substitute the values for B, you have to remember to substitute it as negative px. And of course, the values for n is 6. Right, so we're all ready to do the substitution. Right, so the first term is a to the power of n, which is just 1 to the power of 6, followed by 6 choose 1, followed by times 1 to the power of 5, and remember to bracket the b term because we have a negative there. So it's bracket negative px, close bracket to the power of 1. Right, so let's continue. Yes. The arrow is just to remind you that it's bracket negative px, close bracket to the power of 1. Right, so you would have observed that this 5 plus 1 will give you this number 6 here. Alright, let's go on to the third term. All we need to have are 3 terms. So let's go on to the third term, which is 6 choose 2, 1 to the power of 4 bracket negative px, close bracket to the power of 2. And again, if you were to take note, this 4 plus 2 will give you this n equals to 6 here. Okay, so that's all we need. And the next step is just to simplify the expansion. Right, so 1 to the power of 6 is just 1. And then 6 choose 1. You can just use your calculator. 6 choose 1 is just 6 shift. On your calculator, you will see NCR. So 6 NCR 1, that gives you 6. And 1 to the power of 5 is just 1 to the power of 5 is just 1 times bracket negative px. Okay, do not remove the bracket until the last step. And 6 choose 2 is just 6 shift NCR 2 on your calculator, and that gives you 15. And 1 to the power of 4 is just 1. And here, alright, you just have to be careful. When you expand this, it means negative px multiply with another negative px. So the negative and the negative will give you a positive. The p times the p will give you a p squared. And x times x will give you your x squared. That explain how we get p squared x squared. And let's simplify further. And this will be your 3 terms that are needed in this expansion. Right. Right, so usually for O-level questions, right, part 1 will be you're asked to do some simple expansion. Usually it's the first 3 terms or the 4 terms. And then in part 2, you are asked to use this binomial expansion to multiply with another expression to find a certain coefficient. And in this case here, we asked to find the coefficients of x squared. Alright, so we have found the expansions for bracket 1 minus px to the power of 6. I've written all the three terms here already. And we're going to expand it with this to find the x squared term. Alright, so we're not going to use distributive law to expand all of it. It's very time consuming. So how are we going to do it? So first of all, we're going to take the first terms in your first expression, that is number 3, to multiply with 1. And you will get 3 times 1 gives you 3, which is obviously not what you're interested in, because what you're interested in is the term x squared, the x squared term. Something x squared, so it could be ax squared, where a is the coefficient. Right, so we're not interested in the constant term. Okay, so let's forget it. And then you take the number 3, multiply with negative 6x, it gives you negative 18px. Again, it's not what we're interested in because we're interested in the x squared term. So that's forget it. And then you're going to take 3 to multiply with the last term, which, yes, you end up getting 45p squared x squared. So this is what you want, so that keep it. And then we proceed on to the second term in your first expression, which is 2x. We multiply by 1, that gives us 2x, which is not what we're interested in, so let's forget it. And then you take your 2x times negative 6px, and yes, that gives us negative 12px squared. So I want that, so let's keep it. And then you take it again, multiply with the last one, that will give you x cubed term, which is not interested, so let's remove it. And then finally go on to the last term in your first expression, which is 3x squared times 1. And yes, I want it because that gives us the x squared term. And then go on to the next one. No, that gives us the x cubed. And go on to the last one, give us x to the power 4. Also, no. So the last two, we're not interested. Alright, so therefore this orange and the black color and the red colors are what we want. So let's expand it. Yes. And let's factorize your x squared, because we're interested in getting the coefficient. So the coefficient means is the number or the variable in front of the x squared. So therefore the coefficients of x squared is 45p squared minus 12p plus 3. Right, so the concepts needed number 2 is to know how to use the general term, right, to find constant term, or to find the x squared term, or to find the x cubed term. Basically just to find a specific term in the binomial expansion, because sometimes the binomial expansion we can have up to 100 terms, and it's very pointless to just to expand it to find all the 101 terms just to get the 6th term or the 7th term, right? So knowing how to use a general term is very important, because it helps us to find a specific term that we are interested in. So in this question here, we are told that the constant term is 5376, and you're asked to find the values of p. Right, so as what we have done, similar with what we have done earlier, let's compare what you're given to find the values of a and b and n. Oh, and before that, yes, the one that is shown on the screen, the boxed one in brown color, this is the formula. This is your general term formula to find a specific term. Yes, okay, right. And why is it theta plus 1? Because if n is equals to 9, basically we are getting, when we expand it all out, we should get altogether 10 terms and not 9 terms. we'll be getting 10 terms altogether. Alright, so therefore, the general term formula is TR plus 1 and not TR. Okay? Meaning if we are finding the 9 terms, then your R is 8. Okay, it's 8. If you are finding the 13 terms, your R is 12. Alright, so let's write down the values of A, which is x squared, your B, which is P over 2x, and N equals to 9. So we all set to put inside the general term formula. Oh yes, something to take note, which is very important. Because you need to acquire, I said acquire because you can actually acquire it through practice. So you need to know how to break this guy up into 2 separate terms. So P over 2x is the same as P over 2 times 1 over x. It's the same as taking P times 1 to give you P, 2 times x to give you 2x. So we break it up into P over 2 times 1 over x. And then you were to recall the rules that we have learned in the chapter indices. You can break it up into a to the power m times b to the power m. So we can break it up into P over 2 to the power r times 1 over x to the power r. So this is important. You must know how to do that. Alright, so let's do your general term formula. Substitute in the values for n, for a, for b. Okay, and here, right, how do I get 18 minus 2r? Basically, you just take 2 times 9, it gives you 18. 2 times negative r gives you negative 2r. And again, here we are using the rules we have learned in the chapter on indices. Okay, right. And some of the rules also, if you have to recall, 1 over x is basically 1 over. Right, so if you recall 1 over x, you have learned in the chapter on indices, 1 over x basically is just x to the power of negative 1. Right, 1 over a to the power n is equals to a to the power of negative n. Okay. Right, so let's continue with what we have stopped just now. Right, so the next thing is that I'm going to group all your x terms together. And then I can apply these rules again, where a to the power m times a to the power n will gives you a to the power m plus n. So therefore, you end up to get x to the power of 18 minus 3r. Okay, I need to erase this. Okay, right. So the questions asked for the constant term. So the constant term refers to the x to the power of 0 term. Basically, constant terms are terms without the x variable there. So it could be like the number 2 or the one that we are told. The constant term is what, 5396 if I remember it correctly. Okay. So we have to equate 18 minus 3r equals to 0. We need to find where is this term hiding. Yes, where is it hiding? So when we equate it to 0, we find that r is equals to 6. So this constant term is the 7th term. It's hiding there. Okay, it's a 7th term. Alright. So with this value of 6, we can substitute back into this general term formula we have found early on and equate it to 5376. Did I say 5376 just now? Okay, never mind. Right, so we can equate it to 5376. Right, so you can basically use the calculator to evaluate 9 choose 6 to get 84. And of course, it's a constant term, so that's x to the power of 0, makes sense. And if you take 5376 divided by 84, you get 64. Right, so to find p over 2, you just put 64 to the power of 1 over 6. And 64 to the power of 1 over 6 is 2. So p over 2 equals to 2, therefore p is equals to 4. So this is how we can use the general term formula to find a specific term. Right, let's do an additional practice. You may want to pause the video to try to do the questions on your own. Right. So you asked to find the term independent of x in the expansions given. Right. So I've highlighted for you. Very important is to compare what you are given with the variables in the binomial theorem. So here we are given a is x squared, b is negative 1 over 2x cubed. Okay, watch out for the negative. That's why I put the arrow there. And n equals to 15. All right. So the next thing to ask yourself is, what do you mean by the term independent of x? Basically, it refers to the constant term. It means the x to the power of 0 term, which is the same concept as what we have done earlier in the earlier example. Right. So it'll be good to try it on your own before you look at the solution. Okay, so first thing first, let's write down the general term formula. If you cannot remember the general term formula, you can always find it in your binomial theorem. Alright, so now let's do the substitution. And let's break this up. Now, when you break this up, okay, just remember there's a negative here. Always tag the negative to the number. That means don't tag it to the variable. The variable I'm referring to is your 1 over x cubed. Don't tag it there. Tag it to the number. So it could be like negative half, negative 1/3, negative 3/4. Right. The reason is later on I'm going to combine this with this. Okay. So it has to be in the same format. So if you look at what we have here, it's a positive x to the power of 30 minus 2r. Okay, so I need to keep this as positive 2. Therefore, I have to give the negative to half. Alright, so let's continue. Okay, so I'm going to equate 30 minus 5r equals to 0 to find the term. So r equals to 6, so we're interested in the 7th term. Right, so substitute again r equals to 6 back to this guy here. And you will get 78, 13 over 64 as the answer. Right, so please try it on your own, and I hope you get the answer. Okay, concepts needed number 3 to do well in this chapter on binomial theorem is to understand what does NCR refers to. So on the calculator, NR means NCR. It refers to on the calculator, you'll see this NCR symbol. So there are some concepts that you need to know. What does NR means? It means n factorial over r factorial times bracket n minus r factorial. And what does n factorial means? It means the whole chunk of thing there. So for example, if you need to find, let's say, 6 factorial, it means 6 times 5 times 4 times 3 times 2 times 1. Let's have another example. Supposing you ask to find 3 factorial, or it means it's 3 times 2, 2 minus 1, just 3 times 2 times 1. So let's do another one. Let's say it's 4 factorial. Just start with 4, then 4 minus 1 to get 3, and 3 minus 1 to get 2, and 2 minus 1 to get 1, and that's it. Okay, we're not going into much detail. We're just going to learn how to use it, that's all. Okay, right. And you also need to know how to evaluate this. What does this mean? It means it's n factorial over 3 factorial and bracket n minus 3 factorial. So n factorial means start with n and then n minus 1, n minus 2, n minus 3, n minus 4, so on and so forth, right? So 3 factorial means 3 times 2 times 1. And I'm going to leave this alone. Why I want to leave this alone? Because you will realize that from here onwards, your n minus 3 times n minus 4 times n minus 5, blah, 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 actually is your bracket n minus 3 factorial. Okay, so this and this can be cancelled off. So basically, n choose 3 can be simplified as this. So let's have another example. Let's say if I have n choose 2, what does it mean? It means you start with n first, followed by n minus 1. 2 terms. If this guy is a 2, then you just, on the numerator is 2, denominator also 2 terms. So 2 times 1. Let's do another one, okay? For example, if you have n choose 4, what does it mean? It means n followed by n minus 1, followed by n minus 2, another one more. I'm supposed to have 4 terms altogether, so 1, 2, 3, 4. Over, start with 4, minus 1, minus 1, wait, minus 2 fast. Alright, so this is what you need, the concepts that needed. Right, so we need to understand some basic properties of your n choose R. What does n choose R means? Yes, so if you to refer to the earlier slides, n choose R means n factorial, right? Followed by R factorial, then n minus R factorial. So sometimes in the test or exam questions, you may ask to evaluate, for example, 5 choose 2 without using the calculator. Meaning you're not supposed to just use a calculator, press 5 shift n0 to give, you can do that using a calculator. What I'm saying is you're not supposed to just give an answer 10. That means if you just give an answer like this, you won't be getting any marks. The answer is 10. After using the calculator, answer is 10, yes. But if you just show just the answer 10, you will not get any marks. So what are you expected to do when it said without using the calculator? What are you expected to do? So you're expected to show all these steps. So 5 choose 2 means 5 factorial, right? Over 2 factorial. Over 5 minus 2, that's 3 factorial. So you basically you need to show all the steps. So 5 factorial is just 5 times 4 times 3 times 2 times 1. So 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. So we can do some simplification here. And yes, you get the answer 10 when you use your calculator. Right, so without using the calculator means you have to show this step, and finally your answer. That's what it means. Okay, that's example 1. So example 2, you're asked to express n choose 3 as a polynomial in n. So we have done this earlier on already. So n choose 3 means start with n followed by n minus 1 followed by n minus 2, then over 3 times 2 times 1. Okay, and some other things we need to know, like n choose n is 1, n choose 0 is 1. So these are the basic properties you have to take note, because you may be using either the properties or maybe asked to evaluate, like for example in example 1. Right, so we're going to do concepts number 3. If you look at the questions, right, if you were to compare with what the variables in the binomial theorem, you see that n is unknown. For all the examples we have done so far, we know the values for n. It could be 6 or 7 or 9. In this case here, your n is unknown. Therefore, we need to know, we need to apply the concepts we've learned in the earlier slides. Okay, right. So first thing first is that we're going to do the substitutions into the binomial theorem. Okay, and then the next thing is to compare, because in the questions it says that when I expand bracket 2 plus 3x to power n, I would get this. I would get this. Right. So all you need to do is when you do your binomial expansion, you just need to expand up to x squared. You don't have to continue with n choose 3, because that will give you x cubed term. That gives you the x cubed term here, which if you look at what you are being given, it only stay up to x squared. So therefore, you just need to give the first one to the first three terms. You just need to give the first three terms. Okay, and then you compare with what you're given. We can see that 2 to the power n is equals to p. And this one is comparable with qx. And this is equals to your rx squared, which we will continue in the next slide. Right, let's continue what we have not finished in the previous slide. So this is what we have found. Okay, so basically we're just going to work on the center one, work on this. How are we going to work on this? So n choose 1, if you were to recall, it's just n. And then you can just divide both sides by x. So the x and the x goes off. Right. Likewise, for this term here, you can just divide by x squared throughout to get only n choose 2 times 2 to the power n minus 2 times 9 equals to r. And in the questions, this is what we are given. Right, so we need to square the values for q over p times r. So p is 2 to the power n. So you can just substitute your p here to be 2 to the power n. Okay, so here comes the tricky part. What's the tricky part? Alright, so I need to simplify this term. So this will give me 2 to the power of 2n minus 2, right? Okay, and this and this, if you were to simplify then, can you see that will give you 2 to the power of n minus 2 plus n, and that gives you 2 to the power 2n minus 2. And therefore, we can have some cancellations at the numerator, also at the denominator. Let me erase it since I've already explained to you. If you don't quite get it, just reverse back. So I can just cancel this guy, right? And of course, the 9 in the numerator divided by 9 at the denominator will give you 1. So what is left is only n squared. This one here, and 8 over 3. So what I've done is just do a cross multiply, where I take 8 times bracket n choose 2, and then 3 times n squared. Okay. Right, correct. So this is where you need the knowledge that we have learned early on, that you can actually simplify it into n bracket n minus 1 over 2 times 1, where we have it here. And then you can simplify further to get a quadratic equation where you can factorize your n to get n equals to 0, which does not make sense, so we reject the value, so therefore n is equals to 4. Right, so this completes the whole video on binomial theorem. Right, so if you want more practice, do refer to the links that I've posted. Right, so all the best.